So let me explain to you our virtual model of the game. We have made this virtual model over Tinkercad. As you can see, we have used uh, a lot of components here, be it LEDs, photoresistors, the LCD display, the piezo, and the different wires and the resistors. Here, we are missing a single component, which is our lasers, since we were not able to implement them through Tinkercad. And the photoresistors here work manually. And I'll operate the photoresistors manually. So let me start simulation and show you what happens. This is the initiation of the game, and we have different photoresistors here. I need to set them to maximum light that they'll be getting. Here's round one, wherein it lit up the red LED, and hence I have to select the red LED in time. Here's round two, where I have to remember the sequence of two LEDs, which is the red and then yellow. I did. So it shows correct. And the next round, I'm on round three now. So I press red, then I press yellow, and then I press yellow again. It shows correct. Next round. And this will go on until round number 10. And if someone is able to do the round 10 correctly, they'll win the game. What if I leave it here? What if the time goes to zero? It says time over, and it says it'll restart the game. So now we start from square one. So here, what I'll do is I'll intentionally select the wrong one. It says incorrect, and it will restart. Now that we've seen the demonstration, let me show you the code. This is the code that makes the whole thing work. So it is a pretty simple code, although it looks lengthy. We have the setup function here. The setup function is responsible to register all the input and output pins. I have also used a random seed function here, which I'll be explaining later. So we have the loop function, first of all. These are basic IO commands like for the LCD and for our piezo to start the game aesthetically. We start with our while true loop. So this while true loop is the main game, we could say. This is what will run our game, and when the user inputs incorrect, or the time is over, or the game is won, then only will the while true loop end. It'll be broken. Here is our random function that generates the random LED each round out of the four LEDs. So remember, I used random seed function earlier in the setup function. This is just so that our Arduino gets a random it gets random values for all these LCDs at each startup. Otherwise, what happens is Arduino has a set random function, and at each startup, it would have the exact same sequence of LEDs, which I did not want. So what it does is it picks noise from an unused analog pin A5. As you can see, A5 is unused, and it picks noise out of it, and it generates some random seed for the random function. We add the random number into a sequence, into an array, just so that at each round we first of all play the past LEDs in the sequence, and then add up a new LED, which is generated by the random function. Here it plays all the past sequence along with a new LED. Here is our input. Here is our input checker. So this get input function, what it does is it checks for input, and also it gets the coordinates of whatever input is there. So what we have done is we have kept a time limit of 5 seconds for each LED. Here it first of all reads all of the pins, all of the photoresistors. Um, it also displays time left, and it updates the time left at every 0.5 second or 500 milliseconds. So if we have done something correctly, it would say 1 out of 4, 2 out of 4, 3 out of 4, and 4 out of 4, just so that we know when the round will finish. Uh, Here it checks if exactly 1 out of x1 and x2 and y1 and y2 are pressed, and then it checks which coordinate is it exactly. After it is done checking, it will here it will light the LED, whichever one we have input. It will also see if our time is zero, and if our time is zero, it will say time over, and we'll then what will happen is the game will restart. So here we have our array. So get input, it gets me an array ARR. It checks here that if our input matches the sequence that is there in our sequence array. If our sequence does not match, it says that incorrect, and it also breaks out of uh, our for loop here. It also changes the state to false. If our state is false, it will say restarting. and it will also break out of the while true loop. So we'll exactly start with the game from the beginning. And here is our winning condition, that if we are at round 10, since j starts from 0, if we are at j equals 9 or round 10, it will say thank you for playing. It will play some pleasant tone, and the game will restart from the beginning.
Uh, so the connections from the photoresistors over here, photodiodes are connected to the analog pins over here. The lasers are connected directly to the battery because they don't really need controlling. It's just the input that's been regulated. The LED lights are connected to each of these high-low pins. Okay, wait. The LEDs are connected to the high-low pins over here, and there's a 9-volt input to the win pin. Can you see? Yeah, so the win pin has a high volt connection, 9-volt connection, and a 5-volt line goes to the laser diodes. Uh, there are resistors connected to each and every LED, as well as the photodiodes to control. There's a piezo buzzer which gives out a small ping as soon as you an input or there is movement in the round numbers or the game restarts. So yeah, and this is the soldering that went into this. This is faulty because it only displays one line over here. I can turn it on, but yeah, I mean this only one line works. This is the physical prototype of the project that we've made. So as you can see, there are laser lights here and photodiodes, which are what allows the input to be taken. There are LED lights which turn on at random sequences and proceeds as the game moves further. This is the LCD display, which is not working at this time, but can be replaced for a non-faulty one. This one turned out to be faulty. So what happens, for a rough explanation of what happens over here, there are lights going on. So these lasers, they shine at these photoresistors, and when we intercept the light rays, the photoresistor corresponding to that light will not be illuminated, which the Arduino can detect. So the Arduino turns on random lights, which we have to remember. So this, now we have to input it. So this takes the input. We move on to the next round, which would have been displayed over here, but the LCD turned out to be faulty. So input and another input. It's correct, and it will move to the next round. Input, input, input.